Hello everyone, you are welcome to solve this nice and interesting algebra math problem, which is c times c minus c times c times c is equal to 2. So we will try to find out the value of c. How can we solve this problem? Look to the left hand side here, c is 2 times, so therefore we can write this as c square minus, here c is 3 times, so we can write this as c cube, and here we will move this 2 to the left hand side, so it will become negative 2 is equal to 0. This we can write this minus 2 as minus 2 can be written as minus 1 minus 1. Adding these two numbers, it gives a minus 2. So therefore we will replace this negative 2 with this one number. So this equation will become c square minus c cube minus, this will become minus 1 minus 1 is equal to 0. Let us combine this one with c square and this one with c cube. So this will become c square minus 1 minus c cube minus 1 is equal to 0. And we can write this one as 1 square and this one as 1 cube. So next we can write this equation as c square minus 1 square. Now here we will take negative sign common from these two terms. So this will become c cube plus 1 cube is equal to 0. Now here in these two terms we will use two different algebraic identities. Here in the first one we will use a square minus b square algebraic identity, and here we will use a cube plus b cube algebraic identity. So here we will use these two identities. In the first term we will use this one identity, a square minus b square, which is equal to a minus b times a plus b. And in the second term we will use this one identity, a cube plus b cube, which is equal to a plus b times a square minus ab plus b square. So using these two different algebraic identities, here this equation will become, in the first term we will use the first one identity, so this will become c minus 1 times c plus 1 minus, using this identity here, this will become c plus 1 times c square minus c times 1, which is simply c, plus 1 square, which is only 1, is equal to 0. Look into both the expressions, both the terms here, c plus 1 is common. So we will take out c plus 1 common from both the terms. This will become, taking c plus 1 common, so here only c minus 1 is left, minus, and here only this quadratic equation is left, which is c square minus c plus 1 is equal to 0. Now let's further simplify this expression. So this will become c plus 1 times, this will become c minus 1, this will become negative c square, this will become positive c, this will become negative 1 is equal to 0. So let's further simplify this expression. C plus 1 times, this will become negative c square, c plus c is 2c, so this will become 2c, and negative 1 negative is 1 is negative 2 is equal to 0. Now here the product of these two expression is 0. So here either this expression will be 0 or this one will be 0. So from here we will get two equations. The first equation is a linear equation, c plus 1 is equal to 0, or the second equation is a quadratic equation, which is negative c square plus 2c minus 2 is equal to 0. Here first we will solve this one equation. So here we will move this one to the right hand side, so it will become negative 1. So c is equal to, it will become negative 1. So c is equal to negative 1 is our first real solution. Now we will solve this one quadratic equation for the other two values of c, for the other two solutions. To solve this quadratic equation, first we will try to make the coefficient of c square positive. So for that you multiply both sides with a negative number, negative 1. So this will become Let's multiply -1 with both sides. So this will become here, the multiply -1 with each term, the sign of each term will be changed. So the negative will become positive and the positive will become negative. So this will become c square, this will become negative 2c, this will become positive 2, and multiplying any number with 0 is always 0, so this will become 0. Now this is a quadratic equation. Here we cannot solve this quadratic equation by factorization method or by completing square. So here we will use the quadratic formula to find out the roots of this quadratic equation. To use the quadratic formula, first here we will write the values of a, b and c. And here the value of a is 1, the value of b is -2, and the value of c is positive 2. The quadratic formula is c is equal to minus b plus minus square root of b square minus 4ac divided by 2a. Now let us substitute the values of abc from here. So this will become c is equal to -b, the value of b is -2 plus minus square root of b square, b is -2, so this will become -2 square minus 4ac, the value of a is 1 and the value of c is 2, divided by 2 times the value of a is 1. So this further simplify this right hand side, so this will become negative times negative is positive, so it will become positive 2 plus minus square root of, here -2 square is simply 4, so this will become 4 minus, this is 4 times 1 is 4, so 4 times 2 divided by 2 times 1 is 2. Here we will take 4 common from the numbers inside the square root, so this will become 2 plus minus, this will become square root of 4 times, taking 4 commons, it will become 1 minus 2. 1 minus 2 gives him -1 divided by 2. So next we will split the square root over 4 and -1. So this will become, the value of c will become, c is equal to 2 plus minus, this will become square root of 4 times square root of -1 divided by 2. So further this will become 2 plus minus square root of 4 is 2 and square root of -1 is the complex identity I divided by 2. So further we can write this number as c is equal to, this will become 2 by 2 plus minus 2i divided by 2. So here we will cancel this 2 with this 2 and this 2 with this 2. So the value of c will become, c is equal to 1 plus minus 1i or simply I. So when c is equal to 1 plus minus I are the other two solutions. So finally we have 3 possible solutions. One is real and 2 are complex. So let us write these solutions here. So the first real solution is, let us suppose this is c1 which is equal to -1, and the second solution which is a complex solution, c2 is equal to 1 plus I, and the third solution is, which is also a complex solution, c3 is 1 minus I. So finally we have these 3 possible solutions in this problem, in which one is real and 2 are complex.